Welcome to This Explainer. We often think of our local weather as just that, local, like what's happening outside our own window. But today, we're diving into this massive invisible chain reaction where conditions in an ocean thousands of miles away are secretly pulling the strings of your local climate. It's like a giant puzzle. Let's break down the domino effect of a true climate giant, the Super El Niño.
Think about this for a second. How does warm water just sitting in the middle of an ocean thousands of miles away threaten a massive country's entire water supply? Well, we're going to trace a direct line from the vast expanses of the Pacific Ocean all the way to the agricultural heartlands of India. As you'll see, it perfectly uncovers exactly how highly connected our global climate systems truly are. Section 1. Meet the Super El Niño. The chain reaction begins. Okay, so first things first. A super El Niño is a very specific, incredibly powerful climate phenomenon. Basically, it happens when unusually warm water spreads all across the central and eastern Pacific Ocean. And to be clear, we aren't just talking about a slightly warm day at the beach here. We are talking about a massive, abnormal pool of oceanic heat. That sheer volume of heat, that is our first falling domino. Now, if you break down the physical mechanics of it, normally you've got these robust trade winds pushing strongly across the Pacific. But during a super El Niño, those winds just weaken. They lose their juice. And because they lose their strength, that colossal block of warm water essentially dominates the ocean. This directly results in severely reduced moisture traveling all the way over to India. It's a fundamental shift in physics. Section 2. Shifting winds and shifting rain. Atmospheric changes. To put that into perspective, normally those strong trade winds act like a giant planetary conveyor belt. They push weather systems and moisture in a very reliable, predictable pattern right across the Pacific. But when a super El Niño hits, that whole conveyor belt basically breaks down because those trade winds weaken so much. This isn't just a minor breeze dying down, it's a massive disruption of the very atmospheric engine that drives our global weather. Let's look at the exact step-by-step cause and effect chain that links those Pacific changes directly to India's weather. It's a literal 1-2-3 punch. Step 1. The trade winds weaken. Because they don't have the power to push moisture westward, we immediately hit step 2. Rainfall drastically shifts away from the western Pacific. The rain just doesn't make it to where it normally goes. Which brings us to the absolutely crucial step 3. Because the rain shifted away from the west, significantly reduced moisture travels toward India. Think about that. A change in wind in the Pacific literally steals the rain clouds right out of the sky over India. Section 3, India's monsoon risk, the local reality. So what does this all mean on the ground? Well, the southwest monsoon is an absolute lifeline for India. It's everything. And the Super El Niño puts it directly in jeopardy. Because of that reduced moisture we just tracked from the Pacific, there is a vastly increased chance of below normal rainfall. And when the rain fails to fall, the dominoes really start crashing down locally. We're talking drought, severe heat waves, and massive, massive stress on agriculture and water resources. The overarching threat to the region is immediate, and it is severe. The really crucial takeaway here is understanding how deeply these effects cascade through the entire society. It starts with the reduced monsoon rainfall, right? That instantly triggers higher temperatures and punishing heat waves. Because the fields are dry and baking, you immediately see lower crop production, which threatens food security. At the same time, you've got broad water shortages for the general population. And get this, it doesn't even stop at food and drinking water. Because the water shortages lead to lower reservoir levels, the country's hydropower generation takes a massive hit. Just let that sink in. A weak wind in the Pacific Ocean eventually means less electricity generated in Indian dams. No way, right? But that is exactly how connected our planet is. But hang on a second. We've traced the dominoes, sure. But is a dry monsoon absolutely guaranteed every single time a Super El Niño forms? Is the final outcome just locked in stone? Well, that brings us to Section 4, the IOD wildcard, a climate plot twist. Actually, our global climate is an incredibly sensitive and deeply complex beast. The Super El Niño, it isn't the only player on the board. Enter the Indian Ocean Dipole, or IOD for short, along with a few other interacting climate systems. The IOD acts as this massive atmospheric wildcard. Depending on what phase it's in, the Indian Ocean Dipole can actually step in and alter the Super El Niño's impact. It has the power to either reduce the severity of the drought and heat waves, kind of saving the day, or it can enhance those effects, making them even worse. It's a literal clash of climate titans, and the ultimate weather in India really depends on how these systems interact with one another. So I'll leave you with this. In a world with highly interconnected oceans, how vulnerable is our own local water supply? We've seen how unusually warm water in the Pacific can weaken trade winds, shift rainfall, and literally threaten hydropower in India, and how wildcards like the IOD can change the math at the very last second. There is really no such thing as truly local weather anymore. We are all, quite literally, downstream from someone else's ocean. Thanks so much for joining me on this explainer, and we'll see you next time.